really the point is about lowering the barrier to creation with electronics. So Littlebits is an expanding library of open source hardware modules. Each module has one specific function, and they snap together with magnets to form simple circuits. It's all open source, so we have all the schematic layouts, diagrams, board layouts, all of that is on GitHub. This is a button, this is an oscillator, this is something more complicated, I'll get to this. And the color codes are divided into 4 categories. Power, because electricity. Output is anything that has any kind of lights, motors, things that affect the outside world, like an output. Input are human input, buttons, knobs, dials, this type of thing, bend sensors, but also environmental input, motion sensors, sound triggers, light triggers, all the kind of stuff about sensors and monitoring. And then the 4th category is wires, and they start out very dumb. They're just obviously wires, but get a bit smarter. So we have forking and branching, inverters, timeouts, and this kind of stuff, but also analog logic gates, so you can set up simple programming, physical block programming kind of thing. And then the wires get even smarter as we go, and we try and tackle a bunch of different kind of realms of technology and really break them down into modules. We all here understand the benefit of breaking things into small modules and be able to redeploy them in different configurations. This here is a collaboration with Korg. It's a 50-year-old amazing synthesizer manufacturer. This is a modular analog synthesizer that is decomposable and snapped together with magnets. Yes, everyone wants one. It's amazing. Super fun. I have some. You can play with it later. And then the wires get even smarter. So this is an official Arduino collaboration with Arduino. You use the Arduino IDE and flash down through USB like you normally do. If anyone's into Arduino, we've taken the first 3 inputs and outputs and normalized them to the Littlebits snap power system. So this is the IoT track. What is this guy doing here? We also have an even smarter wire, which is the cloud bit. And this is about taking a piece of internet. And we'll get into that in a minute. So as a hardware platform, what does a hardware platform mean? We have a sort of physical API, as I like to think of it. So there's 2 magnets that are polarized, so you can't get the thing wrong. Sorry? Oh, no, you're thinking. Great. That means you're excited. Great. So there's polarized magnet connectors. You can't get the connection direction wrong. There's one VCC pin that holds the power, 5 volts, ground, of course, and then a signal pin in the middle. Varies between 0 and 5 volts, and with this very simple communication can actually come very complex interactions. And then the kind of message bus, if you will, and then there's a power bus that's normalized across the system, and we have, again, the signal pin does all the things. So the point of Littlebits is about first breaking down electronics into that you can be understandable and deployable by people, but even for people who know how things work, like we have this really great kind of left-right thing. Say somebody knows how to do the thing on the right, you take breadboards and futz with wires and this and that, and you just want to make a button, turn an LED on. We have a very funny thing where there was a little video real time on the left and 10 times speed on the right of hooking it up, and the person on the left still had time to read a bit of a book before the person on the right was done. And it's about an abstraction layer, basically. Even if you know how to wire up a button, I did it once and got it wrong. It's not actually as simple as, I'm not actually a hardware guy, I'm a web guy. But even if you know that, you don't necessarily want to ever wire up a button again. You get it, great, can I abstract this and use it with library or whatever? And it's very much this kind of thinking brought into hardware. So what can you do with Littlebits? Here is a crayon lathe. It's just a motor. It's like very slow spinning, safe for kids. It's very fun, actually. There's stuff like this is, play the video somehow. Great. This is a very classic robotics problem, a line-following robot, just made quickly with, it's a 9-year-old in Korea who made 2 light sensors and 2 LEDs, and it kind of, the voltage of the reflection is passed into the motors so that it kind of will turn and follow the line. Very simple, fun stuff. This is a project made with Arduino that it turns out you can sense whether you're, it's funny, we have a rock, paper, scissors theme. You can sense whether you're doing a rock kind of with two sensors on these two fingers, like rock is 0, 0, and paper is 1, 1, and scissors is 0, 1. And then you can take that into the Arduino and just do very simple kind of programming. And this is like, it literally plays the game and keeps score and stuff. And it's maybe not the chess playing robot, but it's pretty cool. It's the kind of thing you can do. Now, back to the cloud stuff. The cloud, I have been now at Littlebits for a year and a half, and the past year I've been doing double duty between kind of running the web team and very much the cloud bit is my little baby. And then the past like 6 to 8 months I've been entirely focused on the cloud bit, launching it, and it is totally about prototyping connected devices. Anytime somebody goes to make now, you make a thing, you make a hardware, you make a toaster. It has to be connected to the internet. So we're seeing really interesting stuff around people in design agencies and product design agencies, experience design agencies, taking this up as, back to the original quote of bringing designers and non-technical and non-hardware technical people into the design process of products and experiences and stuff. And the real thing about the cloud bit, it's about snapping the internet to anything. It's about taking the electronics as material one step further. The internet can be a piece of thing, a material that you can put into stuff and program that interaction, and it should be very natural to people, and it shouldn't be about the kind of engineering that we do on a daily basis. So there's just kind of some mechanics about how the cloud bit works, different ways to interact with it. So there's a first level of kind of direct manual readout and control. It's a Wi-Fi bit, so there's a very simple kind of setup process. You get it on the Wi-Fi, it connects, and then we have a kind of a web-based app thing that you can press the button and trigger it and manually control. It's, you know, because we have this one signal pin basically that we get to do fun stuff with, so we can control that. In this case, you would have a slider, and you can get kind of remote readout of what's going on the input pane on it, and you can do this kind of level. We have another level which is about automation, and partnered with IF, and we have a channel on IFT. And of course, everyone at the IFT party can talk to anyone else at the IFT party. So from this, you can use little bits, I don't know, a light sensor to control the brightness of your Philips Hue lights, or Facebook likes or Instagram can make bells go off in your house, whatever you want to do to connect kind of hardware and software. And then the third way is probably a more natural way for this crowd is about the coding with the API and stuff. So the idea being you have immediately a piece of hardware that snap together easy. It has an API kind of inherently attached to it, and you can just kind of do the things that is natural for me to do in order to control things that are beyond my kind of realm of expertise, like in the hardware realm. So then the types of communication, you can go from the bit to web. Again, you can have sensors or things. A classic one is like very quickly rig up a doorbell, and it will go through IFT and send you a text message. If you're in your backyard, you can still know if someone's at your door, this kind of thing. With the cloud bit, again, any kind of internet service, or anyone can ping the API and trigger something on the hardware. And then we also have a kind of one-click direct M2M communication, where one hardware will talk directly to the other. And it have, that's kind of sensor things, direct control of things. Fun stuff. You can have like, I don't know, remote Morse code across the world or whatever it is. Fun stuff. I'm going to just show this and think about it for a second. As we're doing thinking about the types of things that you want to build with this kind of system, they fall into different categories around the types of thing you want to do. You want to get a notification that something happened, whether that's hardware to software, software to hardware, whatever. A remote control is the obvious one. As we were making it, this quirky air conditioner thing came out. I don't know if you've seen this. The idea being the guy wanted to be driving home and take his phone and press the button and turn on his air conditioner. And we saw him, oh, great, you can make that with cloud-based, no problem. Automation is the idea things happen and there's not a person involved. Communication is, of course, there's a person at each end doing something. We have fun examples of this. And then the other one, of course, especially in the industrial Internet of Things. I mean, IoT as a buzzword, people at like a GE and I don't know, these big companies are laughing at us. It's been like this for 30 years. It's about remote sensor networks, and like that's just how technology works. But anyway, the consumer Internet of Things, I like to call it, is the hip thing these days. But we can do stuff around collecting data, frequency, sensor readings, and all this kind of stuff. So again, what can you really do with this? A lot of people, if you're not in the kind of DIY maker kind of world, sometimes it can be a bit like, what are you actually going to do? I want to buy a thing and have it work. And this is exactly what's going on in the consumer internet. If things, there's on one hand, you buy a thing and make it work and it's a shiny product and it does what you want. And on the other hand, you have a bunch of very actually cool platforms and hardware and stuff that you can connect, and you can make devices or whatever you want, but there's a very high barrier to entry on hardware or software or both, and actually very few people are very skilled in hardware and software, and it's a difficult thing. So a few examples. The SMS doorbell maker, great, very much a use case. Someone has plugged into API, I forget whether it's API or IFT, but that will say what's the surfing weather at a particular beach, and like have just, they can glance back and it will say whether they should go surfing this day. Someone was like, have this art be a sunny day unless it's been 3 days since I went to the gym, geofencing, and then make it a rainy day. And people do it for their own kind of inspiration. Or how about very strange things like monitor the amount of chicken feed in the feeder to make sure your daughters feed the chickens, I don't know, and so you can quickly remote see what is the level of the chicken, or if you have to refill it, or what. Anyway, funny stuff. So what the hell does this have to do with Node? Isn't this a Node conference? So we have, of course, made a bunch of cloud stuff in Node. It's very fun, and we've done interesting stuff. We had at some point, if you should for sure meet Jason at the back, who's the brains of the operation. At some point we had done a bunch of, got to a certain point and are like, wait a second, we've been staring at this for so long. Are we insane? And so we called Nearform and guys, can you come just make sure we're not insane? Is this ridiculous? And Richard and Matteo particularly were like, yes, this is good. You should really do that someday, and you got to do this now. And we're like, okay, yeah, great. Thanks a lot. That was a big help. And then it takes me to the actually kind of codey part about this. And there's a bit of a challenge in this out to the community, as it were. So infrastructure. We have a thing now. This very ugly infrastructure diagram. I told myself for sure right away I would go back someday very soon and make it pretty, and I never did. And it's about, you see series of microservices and things and kind of inter-service communication. Right now we're using Redis PubSub for a lot of stuff. We have the servers that the cluster of servers that the devices connect to, different APIs and servers, and they all talk together and it's fun. And they go out to IFT and the internet and all this stuff. We're going to get very soon to a much more beautiful, maybe harder to see on this slide, but Jason's representation of kind of 2 steps where we want to go, and it's way more about us, just a better kind of way. The kind of way we've seen microservices laid out in a few other slides of where you have kind of different things, and then maybe a main kind of rapid stream of all event bus and microservices plucking from the stream of events, all this kind of stuff, and then takes me back to this kind of idea. So we know how to do, let's pretend we know how to do this on the right. We know how to do it, and do we want to spend our days doing this if we can spend 3 seconds snapping things together? I don't. I know how to engineer stuff. I know how to kind of lay out structures and architecture of servers and clusters and load balancers and this, and how things are supposed to go together, and then maybe rig up kind of complicated deployment things and deployment between clusters and kind of ecosystem things. You see I'm doing a metaphor thing, right? Ecosystem things and how the whole platform as a series of microservices should connect and deploy a new stage environment of this whole big system-y thing. And what I really want is this is the thing, it does this, and then I plug it in, and then I do this, and then I really want this kind of thing for large-scale, real-time distributed systems is what we need to be doing. Because we have, we're producing a production of 10,000 of the bits and 20,000 more, whatever. It's serious stuff, and they all open TCP sockets and ping their values at multi-times per second, and it's all streaming, and our app is all real-time, has a WebSocket and a streaming API, and everything wants to be immediate. And the features we're going to be getting into this kind of a big, crazy real-time pipeline is why if this is where the world is going, I think this is where the world, everything stream, real-time connected, everything, how many times can we re-engineer this? Or like, what is the usable abstraction of this kind of thing that, so we don't have to be engineers? Yes, we know how to do it. I don't want to do it. I want to pluck things off the tree of, and plug them together, and then they magically do things. And I like to think I engineer by last resort, basically. And I like to plug things together and make them work. I like to accomplish things. I like people to see that things are being accomplished. And the amount of engineering, for me, engineering is always getting in the way of doing something. Because like, instead of doing something for somebody, I'm like engineering something for myself in order to be able to do that. So, I mean, it's fun. We're engineers. We like to build stuff and tinker things, and like the composability of stuff at that level is amazing, but the amount of engineering and hardcore stuff we have to do is not there yet. It's perfectly acceptable for me as a programmer, as an engineer, to not know how the microservice and message bus layer is working within my computer. That's perfectly acceptable. I think it should be perfectly acceptable that as a systems engineer and like application developer in large-scale distributed real-time systems, I don't have to think about exactly the communication between all the stuff. There should be kind of modular nature of it. So anyway, that's the kind of challenge of that I think a lot of people are trying to tackle right now, is about this infrastructure piece and modularizing and automating the infrastructure piece that right now in Node is solved at the application level, that should totally be solved at the infrastructure and big systems level. Anyway, that's what I have to say.